Today we are going to learn how to solve two-step equations using inverse operations, just like we used to solve one-step equations. Okay, so we're going to circle a variable and then we'll be boxing the constants. Okay, let's look at an example. So instead of having one single number that keeps the variable from being alone on one side of the equation, now we have two numbers, or two operations. So instead of being one step, we need to take two steps, or perform two inverse operations to get the variable by itself and solve. Okay? So in the first example here, you see that they have circled the variable of x. And what is keeping the x from being by itself is a positive 6, or plus 6, and the multiplication of 3. When we are solving a two-step equation, we're going in backwards GEMMA order. So normally we would do grouping, exponents, multiplication, and addition. Multiplication, division, addition, subtraction. But because we're taking an equation apart, instead of combining it together, we're going in the opposite direction. And so we always start with the inverse of addition or subtraction. So we're going to box any additional constants that we have. A constant is without a variable. It has a plus or a minus in it. Okay. So let's look at how we would do this in a real problem. So our first problem is 3k plus 5 equals 23. The k is our variable. So let's circle it. I'm going to change my pen size here a little bit for us. Okay, so circle the variable. This is the number we want all by itself, or the variable we want all by itself on the left. Now we're going to put a box around the constant, or the number that's not attached to the variable. That's the plus 5. In your box, make sure that you're including the sign so that you know whether it's an addition or a subtraction. Now we draw a line down the middle so we know to keep both sides of our equation balanced. Let's start the first step of our two-step equation. We're going in reverse order, so we get rid of the number in the box first, the constant. This constant is adding 5 to k, so the inverse is subtracting 5. Whatever we do to one side, we need to do to both sides. And we draw a line and bring down what's left. This is canceled out. Plus 5 minus 5 is 0. So now we have 3k plus 0, but we can just write 3k, right? We don't need that plus 0. And then on the other side, we have 23, and we have taken away 5 to keep it balanced. That gives us 18. Now we're down to a one-step equation like we've done before. And in this case, we have a number and a variable right next to each other with no operation in between. If we don't see an operation, then we know that what we should do is multiply. So this is multiplication. That means the inverse, to take it apart, would be to divide by 3. On both sides, we divide by the coefficient, the number in front of the variable. So 3 divided by 3 cancels out, makes 1k. We'll bring that down. K is the only number left on this side, and it is equal to 18 divided by 3 is 6. And now we can check our work by substituting in. We have 3 times k, so we leave parentheses just like when we evaluate, plus 5 should be equal to 23. Our answer was 6, so we put that in the parentheses to evaluate. 3 times 6 is 18, and then 18 plus 5 is 23. Excellent. When we substitute it back in, if we get the same answer, then we know that we got the correct answer for x. Let's try another one together. First thing we do is find the variable and circle it. It's kind of small, but it's up here. P divided by 2. And then the constant is the one that's not directly attached to it. You'll notice that the 7 is the one off to the side. That's a constant without a variable. Do you see how it doesn't have any number in front of it? If it doesn't have a number in front, that means it's a plus or a positive. Draw a line, And now we use our inverses to solve. We always do the constant or the adding subtracting first. If this is a plus 7, then we subtract 7 on both sides to solve. That cancels out, and we bring down the p divided by 2. We could bring down the plus sign, but it doesn't really help us since we know that it's already positive. It's assumed to be positive. Equals 27 or 22 minus 7 is 15. Now, this is divided by 2, so the inverse operation is times 2. Multiply by 2 on both sides, cancels out our division, leaving us with just p is equal to 30. If we evaluate by substituting it back in, we get 7 plus, and then our number, our p, divided by 2 should equal 22. Our p was equal to 30, so we substitute that back in, and we get 7 plus, 30 divided by 2 is 15. And we know that we did it correctly because 22 is equal to 22. Great. Let's take a look at some on the back. Now this one is a little bit more challenging just because we got a little lost. If you're looking for your x, you're not going to find it on the left. When we look for our x, this time we notice it's actually on the right. So we circle our variable, and that means that this time, instead of working on the left side, we're going to be working on the right side when we do our inverses. The variable can be on any side. It doesn't matter. We do the same process. Right? So circle our x. Our constant is this 20. There's no sign in front, so we assume that it's a positive. So our first thing to do is to get rid of the plus 20 by using the inverse of subtraction. Subtract 20 from both sides and it cancels out. 16 minus 20 is going to be negative 4. And that's going to be equal to, this is canceled out, plus 4x. So we'll just write down 4x because the positive sign is assumed. Now this is multiplication, so the opposite of multiplying is division. So let's divide by 4 on both sides. Dividing on both sides to cancel it out will give us our answer on this side. Negative 4 divided by 4 is negative 1. And on this side, now we have x by itself. Negative 1 is equal to x, or if we'd like, we can turn it around and write x is equal to negative 1. Same thing. Make sure that you perform your check using or evaluating an order of operations by substituting it back in. All right, why don't you try number 4 and 5 on your own, pause the video, and come back and check. Okay, let's see how you did. So for number 4, we circle our variable of x, which is next to the 5, and then we have a minus 10. So our first step would be to get rid of the constant by doing the inverse of addition. That cancels out the negative 10, and on the left, 5 plus 10 is 15, and so now on the right, all that's left is the 5x. To cancel out multiplication, we use the inverse of division. Divide by 5 on both sides. That cancels out the times 5, and on the left, 15 divided by 5 is 3. On the right, all that's left is the x. 3 is equal to x, or x is equal to 3. In problem number 5, our variable is d next to the 6, and our constant is the 6 in the front. Even though we don't see a sign attached to it, we know that it is assumed to be positive. The opposite of plus or positive 6 would be minus 6. When we subtract 6 from the left side, we have negative 30 minus 6 more is negative 36. And then plus 6 minus 6 cancels out, leaving us with just 6 times d. 6 times d, the inverse to get rid of multiplication is division. We divide by 6 on both sides. Negative 36 divided by 6 is negative 6. This cancels out on the right, leaving us with just d. Negative 6 is equal to d, or d is equal to negative 6. Go ahead and try the last problems and then pause the video, return when you're done to check your work. It's really important that you're trying these on your own first. Make sure you give it a try and correct your work if you need to. Okay, let's go through the last two problems together. You should know whether you have them right or not because you should have done your checks, correct? So when I'm looking at the problem, the first thing I do is find my variable. Looks like the variable's back on the left side, and it's above the 9. Then I put a box around my constant, the plus or minus portion. That's the part I know I need to cancel out first. If I have minus 8, I know that the inverse of that is plus 8, and I remind myself to do it on both sides. Now I'm going to bring down what's left after I add 8. When I add 8 on this side, it cancels out the minus 8, and now all that's left is the x divided by 9. On the right side, 19 plus 8 more will give me 27. Okay. Now our next step with division should be to multiply by 9 on both sides. So x times 9 and 27 times 9. Multiplication cancels out the division, leaving me with just x, and then I've got a pretty big number. Feel free to use Desmos if you need to. 27 times 9 should be 243. X is equal to 243. For number 7, go about it the same way. Circle our variable and box our constant. Subtract 11 as our first step, and inverse to addition. Bring down the 7z, and the changed value on the right side. Divide to cancel out the multiplication, and bring down the z on the left and the negative 11 on the right. Z is equal to negative 11. Make sure that you're practicing this a lot because it's a critical skill that you're going to use for the rest of the year.